Hello and welcome. In this video, I want to help you convert a quadratic equation that's initially in standard form into vertex form. Here's the plan. We're going to begin with a quadratic equation that's in standard form, and the goal is to convert this into an equation that is in vertex form. To accomplish this, we will have to complete the square. Doing this set of problems, I'll be under the assumption that you're proficient with completing the square and knowing how to apply this specific formula. If you need to review this idea, I encourage you to check out my other video on completing the square. If not, let's begin with the first example. Example number 1, rewrite in vertex form. In order to rewrite this equation that's initially in standard form to vertex form, I will have to complete the square. To complete the square, I will grab the x squared term and the x term, and then follow this recipe, getting the b term, dividing it by 2, after that squaring it. In this example, the b term is negative 6, since negative 6 is the coefficient of x. So I'll grab negative 6 divided by 2, and then I will square that. Simplifying what's inside of the parentheses first, negative 6 divided by 2 is negative 3. And negative 3 squared is going to give me a positive 9. So to complete the square, I'm going to need to add a 9. But to keep the equality, I am also then going to subtract by 9. So here I'll have x squared minus 6x plus 9. That's going to give me the perfect square trinomial. I have the minus 8, and then I'm going to subtract 9. Recall that whatever I'm adding, I have to subtract it in order to keep the equality. I can begin to simplify the right hand side, and the perfect square trinomial, I can exchange that for a binomial squared. The negative 8 and the negative 9, they make a negative 17. And now I'm going to fill in what goes inside of this parentheses by grabbing x and adding half of the coefficient of x. Here, that's going to be half of negative 6. That will be negative 3. And that would be the vertex form of this standard form equation. Let's look at a different example. Example number 2, rewrite in vertex form. In order to convert to vertex form, I'm going to need to use the x squared term and the x term. Now notice that here, the coefficient of x squared is not 1. We have a 2, so we have to factor out that 2. So I get y equals to 2. And to find out what goes inside of the parentheses, we divide each of these terms by whatever it is that we factored. So 2x squared divided by 2 gives us x squared. And positive 8x divided by 2 gives us a positive 4x. Now that I've factored, I'm going to zoom in inside of the parentheses, and I will begin to complete the square by grabbing the b term, dividing it by 2, and then squaring it. Recall that the b term is the coefficient of x, so here that would be the positive 4. So we're going to grab 4 divided by 2, and then we will square that. Simplifying what's inside of the parentheses, 4 over 2, that's going to leave us with a 2, and 2 squared is going to give us a 4. To complete the square, using what's inside of the parentheses, we will need to add a value of 4. And now I have y equals 2 multiplied by x squared plus 4x plus 4. And then we have a minus 6. To keep the equality, we need to subtract by whatever it is that we added to complete the square. Here it looks like we added by 4, but remember that we have a factor of 2. So in reality, we are subtracting, or we're going to need to subtract 2 times 4. And here's a very nice way of remembering what to subtract when you have a factor other than 1. You will take the opposite of your factor. Because we have a positive 2, that's going to be a minus 2. And then you just multiply it by whatever you use to complete the square. Here that's going to be 4. So we're subtracting a quantity of 2 times 4. Okay, let's begin to simplify things here. I have y equal to 2, and the perfect square trinomial, I can exchange that for a binomial squared. And to find what goes inside of this parentheses, I just grab x and add half of the coefficient of x here. That would be half of 4. Half of 4 is 2. So I have x plus 2 squared. We have the minus 6, and then the negative 2 times 4 is negative 8. The final thing to do is to combine these two terms. So now I get y equal to 2 multiplied by x plus 2 squared, and negative 6 minus 8 is negative 14. And I have my vertex form. Let's check out a similar example with example number 3, rewrite in vertex form. In order to convert to vertex form, I'm going to need to complete the square. And to complete the square, I need to focus on the x squared term and the x term. Noticing that the coefficient of x squared is not 1, we're going to need to factor out that value. So here, I'm going to get y equal to 3, multiply it by parentheses, and then we have that plus 2 at the end. To find what's inside of these parentheses, we grab each of these two terms and divide it by whatever it was that we factored. In this case, that's the 3. 3x squared divided by 3 gives us x squared. And positive 6x divided by 3 is going to give us a positive 2x. Now that I've factored the coefficient of x squared, I can zoom in inside of the parentheses and begin to complete the square using these two terms. In order to find the value needed to complete that square, I'm going to grab the b term, divide it by 2, and then square it. Here, the b term is going to be positive 2, since that's the coefficient of x. So we get 2 divided by 2, and then we square that. Simplifying what's inside of the parentheses first, 2 divided by 2 is 1, and 1 squared is going to give me a 1. So I will need to add a 1 inside of the parentheses. Now I'll have y equal to 3 multiplied by x squared plus 2x, and I need to add the 1 to complete the square, and then we have a plus 2 right here at the end. Now to keep the equality, we need to subtract by whatever it is that we added. Here it looks like we added a 1, so we would think to subtract 1. But we have to keep in mind that there's a factor of 3, so we're actually subtracting a quantity of 3 times 1. So here we can use this little nice diagram to help us remember. We grab the opposite, so here that's going to be negative 3, and we multiply that to whatever it is that we use to complete the square. So here that would be the 1. And now we can begin to simplify things. I will be left with y equal to 3 multiplied by, and recall that the perfect square trinomial, I can exchange it for a binomial squared by grabbing x and adding half of the coefficient of x. So half of 2 would be 1. So we get x plus 1 quantity squared. We have the plus 2, and then negative 3 times 1, that's negative 3. The last thing to do is to combine the positive 2 and the negative 3, and we get a final value of 3 multiplied by x plus 1 quantity squared, and 2 minus 3 is negative 1. And we have our vertex form. Let's practice with one final example. Example number 4, rewrite in vertex form. To convert to vertex form, I will need to complete the square, and to complete the square, I need to focus on the x squared term and the x term. I notice that the coefficient of x squared is not positive 1. We have a negative 1 here, so we have to factor that out first. We're going to get y equal to negative 1, and then we have the minus 40 at the end, and to find what goes inside of this parentheses, we divide each of these two terms by whatever it is that we factored. In this case, that's the negative 1. So negative x squared divided by negative 1 is going to turn this into positive x squared, and then the positive 12x divided by the negative 1 is going to leave us with a negative 12x. Now that I've factored out the coefficient of x squared, I can begin to zoom in inside of the parentheses and complete the square using these two terms. In order to find the value that's needed to create the perfect square trinomial, I'm going to grab the b term divided by 2, and then I will square it. Here, the b term is going to be negative 12 since that's the coefficient of x. So I grab negative 12, divide it by 2, and then square it. Simplifying what's inside of the parentheses first, negative 12 over 2, that's negative 6, and negative 6 squared will give me a positive 36. So to complete the square, I'm going to need to add 36 inside of the parentheses. I'll get y equal to negative 1, parentheses x squared minus 12x, and then I'm going to add 36, and I'm going to subtract 40. Using the pattern that I've been using for the previous examples, I'm going to grab the opposite here. So the opposite of negative 1 is going to be positive 1, so plus 1, and I'm going to multiply by whatever it was that I used to complete the squared, so the 36. And that would give me the correct amount to add or subtract in order to keep the equality. Let's begin to simplify things here. And I get y equal to negative 1. I can exchange the perfect square trinomial for a binomial squared by grabbing x and adding half of the coefficient of x. So half of negative 12 is going to be negative 6. I have the minus 40, and then 1 times 36 is just positive 36. This leaves me with a y equal to negative. I'm not going to emphasize the 1, so I'm going to have minus parentheses x minus 6 squared, and negative 40 plus 36 is negative 4. And that would be the vertex form.